Greetings. I'm excited to share with you a little case study about using burnup charts and quality assurance techniques in order to understand the actual deadline for when software is going to get completed. So let me tell you a little story. A lot of this is made up, but the relevant points are real. I want to protect those involved. Um, Imagine that we're working with a construction company, and the construction company has a really cool idea to automate a lot of the work that it takes to do blueprints. And up until this point, it's been a very manual, laborious job. Someone has to sit down with pens and pencils and markers and draw these stupid blueprints out for the work that they're doing. It takes days. It's a huge time suck. And gosh, if they could only do it in hours or a day or minutes, then they could make so much more money. So they set off to make a piece of software that's going to turn these handwritten sort of approaches to doing blueprints into code. But there's a lot of rules that are involved in creating a piece of software that's going to think about every single architectural detail. It's a hard problem. And the customer hires this software agency to do this work. And at first they said, no problem. We've gotten all the information from you. We're going to have it done by January 6th. January 6th comes around, and either the agency, the software developers are like, oh, actually, sorry, we need some more time. Or they deliver something and the client was like, this isn't what I was looking for. Um, we're not done yet. Oh, right. Okay, we're gonna do some more. We need until March 9th. Client says, okay, fine. And so the March 9th rolls around and either it's not done or it's done in some form, but it's not at all what is necessary to actually solve the problem they were talking about. So then they're like, well, we give us until May. So it gets May, and the same thing happens again. Give us in July. You see the pattern here? This is unfortunately quite common, not just in construction, but in software. But there's tools that we have that can solve this. So when we got involved at Acorn, um, and some of these numbers are made up, but you'll get the point. And we asked like, well, okay, this is really complicated because you can't just have it feature by feature. You have to have a whole collection of features in order to get to the end. Fortunately, some of those blueprints are really easy, and you don't need to apply all 50 rules to come up with a blueprint, and each rule is taking a bunch of time to code. Originally, we thought, oh, well, let's just get an estimate for each rule, and then as each rule gets rolled out, we will we will be able to forecast. We make a list of every single feature, and we estimate it in terms of size roughly, and then as we chunk down, we'll make a line each day, and we'll be able to forecast it. Unfortunately, that was not something that we were able to get to. And I don't know, to this day, I don't know how much this was the team didn't really want to spend that time to estimate, or whether it was more just a really complex issue that wasn't really going to get us to that forecast. The problem was we couldn't just trust the forecast they were giving us because, as you can see, it was never correct. We weren't getting to the goal. So we came up with an idea. Um, we figured out when we thought of ourselves, okay, there's 100 blueprints that this software needs to be able to chunk through and correctly draw out of, let's say, pictures of buildings and stuff. How long does it take for us to just go through and have a human expert verify every single blueprint that it's been drawn correctly? Well, it takes about a day. Okay, well, we can add more than one human. So it was expensive, but it was worth it to have humans that were trained to understand what the feature set was, those 50 features, and could go through systematically each blueprint and just check like, is the rules that we expect to be coded already here, or is it broken? And so they just went through the whole list of 100. They like split it up among, let's say, four different people. Each one had 25. And every day, part of their job was go through all 25 and just be like, yes, this is working. No, it's not working. Red, green, all the way through. And at first, you would see that all of the blueprints would be red because there's no working software. But then over time, each day, one would hope that the team doing the development would be pushing new changes, which would make more and more of those turn from red to green. Because we were looking at every single blueprint every single day, we could do a really cool burn down chart. And so burn down charts, the way these work is you have something that you want to measure in aggregate and you want less of it. You want zero of it, ideally. Doesn't have to be zero, but let's just say. And every single time period, whether that's a day or a week or whatever, you measure how many are left. And since we are looking at defects, we're looking at bugs because we expect it to work in a certain way and it's not. And there's 100 of them. It could be 1,000, it could be 10, doesn't really matter. This concept works. And if you have a deadline that you all agreed on, or maybe there's an event, or maybe it's just a forecast. The team says we think we can get it done by X date. Okay, let's just draw a line from total number of issues that we have all the way down to the bottom. You would hope it would not go higher than that, but it is possible. And then the reality is it's never going to be perfect. In an ideal world, they would work consistently each day, each week, and it would be a straight line down. It's never like that. It's squiggly. It goes back and forth across the across the line. But each time that it's updated, you can do a trend line and you can figure out, are you on track or are you off track? Very helpful. So here's how it worked with this team. So I've put in blue some indicators of kind of what it looked like each week. And let's pretend that the gray line, the dotted line right here, this ideal is what they said that would be done by. And and keep in mind, a lot of times when we're shooting for a specific deadline, I mentioned there was like 50 features. The client doesn't necessarily need all 50. Maybe they need 25. If they had those 25, that's like 80% of the work right there. The other 25 is like gonna have maybe 20% of the impact. So if you prioritize it, there's like a scale where some of them are much more important for us to nail than others. So what this team could have done is just focus on the most important features, and then only once those were fixed for all 100 properties would they move on to the next one. It's not really what worked out in this case, but I wanted to call that out that there's a number of levers that we have to pull in order to make sure that we get to a certain date or to a certain budget or whatever that is. Usually that's removing scope because frankly, it's rare that two different features have the same level of value if we put it out into the market. The other thing too is if you can get one of those features out first, you may discover that that feature has a lot more, a lot less value than you initially thought, and that would change this entire project plan if you discover some important information from the clients, from the stakeholders, from the users. So getting back to this story, we knew that there was a specific goal, and you can see like even after week two, we knew we weren't on track. If you were to draw a line through that trend line, which you can create by just adding the 2 points of the vertical and averaging them between two data points and doing the same thing at the bottom, averaging those two data points, you'll get an intermediate point here, and you'll get one for those as well. So you can do that with groups of numbers, and then you just draw a line through those, and that gives you your trend line. Um, it doesn't sound like it's legit. It is a legitimate way of doing it. It's how the math works. So we could have put actually I'll just do it right now just for fun. You can put a little, say a little dot right there. That's the average. Boop. And then we could do one here. Boop. And if we were to draw a line through this, through those two ones, right through there. It actually gives you the trend line that is for these four data points. So I'll just remove that for now. Um, it doesn't take, so 4 days in or 3 days in, we already would have known, hey, this line is not, it's the the estimate is off. Something's wrong. Can we fix it somehow? Can we accelerate? Can we add more people? Can we remove scope? So you start to play with what your decision points are, what your levers are that you can pull based on information after 3 days. Keep in mind, like back here, this team had been like working on this for a long time, and it's not complicated, but it's very effective. So one of the things you'll notice on this is things got it better, and then whoop, it popped right back up. And we call these regression bugs. So maybe you introduce a new feature that makes things better, but it also reintroduces an old bug in the code from before. So this is totally expected. These sort of blips that come up, and then you write up a new bug, and then you add it. And in this way, so another way that we actually did this analysis is not just look at reviewing all 100 properties to mark red and green each time. We had a separate system just in case to kind of triangulate and sanity check this number. And we just made a list of every single bug. And then we looked at how quickly those bugs were getting reduced. And then more bugs would get added and it would reduce. And so it's this sort of pattern. Same concept, burn down chart. So we actually had two burn down charts that we were looking at for this project. But you can see that even when we had the steepest slope possible, we were not going to hit the deadline of 12 weeks. We were able to start having that conversation about missing that deadline after 3 weeks. So, or 3 days, or sorry, I keep bouncing back and forth between whether these are days or weeks. But you get the idea. Like within a couple of weeks or a couple of days, whatever the time period is, you start having the conversation about whether you're going to hit that, and you can make some contingency plans. Um, even so, if we go over here, I'll show you how that looks. So if we draw some trend lines, these could have been conversations with the client, with the software team, at any of these moments to be like, hey, what is a more realistic date that we can plan around? And while it's not great to go back to the client and say, I know I said 12 weeks, but it's 17. At least we had the conversation back at week 3. Um, we could make plans. We could find out whether we needed to remove scope or what we needed to do because the reality is we were just going to miss that deadline. So that is how we managed to use burn down charts and methods for quality assurance and some very simple graphical methods to visualize what was going on to be able to make better predictions about when things were getting done. And by the way, around week 3, we were forecasting somewhere around here, weeks 14 through 17, and that's exactly when it got done. So even before this, it was interesting to see how we called it. Like we were almost spot on to by the plus or minus a week versus the initial estimate, or not to mention those previous estimates month after month that were given and were missed. So that's a story. Uh, it worked out. Things got done. Client finally had visibility into the work that this agency was doing for them. And we could all celebrate when we finally hit that milestone.